The practice problem says ATP hydrolysis at a neutral pH is accompanied by the release of hydrogen ion to the medium. So you have ATP plus H2O yields ADP plus HPO4 plus hydrogen. If the biochemical standard state for this reaction is 30.5 kilojoules per mole, what is the standard state delta G, that is the free energy change for the same reaction with all components, including hydrogen, at a standard state of 1 molar? Now, first of all, I would like to say I couldn't get my keyboard to plug in a delta right here. Those are both delta G's, not just G. And so we're going to work through this solution real quick. We'll start with the equation. So the biochemical delta G standard state is equal to delta G standard state plus RT. So this is for hydrogen being produced, is plus RT, natural log of H positive times N. N equals 1 in this case, so it cancels out. And so then we're going to rearrange so that we have our delta G. This is the variable we're trying to solve for, so we're just going to rearrange to get it on one side of the equation. So we got delta G standard state is equal to delta G biochemical standard state minus RT natural log of H. At this point we're at a symbolic solution, so all we have to do now is plug in numbers. So delta G standard state is equal to negative 30.5 minus, now RT times the natural log of H. We're at a pH of 7, so that means the natural log of H is the natural log of 10 to the negative 7th. RT is, so R is going to be equal to 0.008314, and T for biochemical standard state is always equal to 298.15, so this is in Kelvin, so that's 25 degrees Celsius. And so whenever we take that times the natural log of 10 to the negative 7th, what we end up getting, and this will pretty much be a constant for biochemical stuff, is you get a negative 39.9538. Negative 39.9538. So we're going to take negative 30.5 and subtract negative 39.9538. And so this subtracting a negative is the same thing as adding. So our final solution, delta G standard state, is going to equal positive 9.4 and that's I believe that's going to be at 3 significant figures, so we would put 9.45 as our solution. And that's all there is to that problem.